Login accepted.
All right, so this is a service mesh for Java developers. However, I don't discriminate by language, except unless you're programming in Scala. Here, I'm going to be... Thank you. It always works. Yes. So in this talk, you should expect something that's... I'm not going to try to convince you that you're doing things wrong or you need to do things differently. I want to present you a different perspective, how you can boost your productivity, basically. And we're going to be talking about few specific frameworks, but again, this talk is not framework specific. Actually, after building this presentation, I'm thinking that I would do like a world tour in doing presentation service mesh for X developer and just switching to whatever famous framework in particular language, because this talk will be applicable for all these languages, believe me or not. So, since I'm in a Java conference, I can embrace some of the past of my times. I started doing Java when it was probably Java 1.5 and Java EE. It was also 1.4. Few of you maybe remember those times. Some people maybe even worked with some of the technologies that were even more older or mature, again, not discriminating by age. However, we remember those times kind of it was everything simple. There was no Kubernetes, there was no cloud, everyone is building on one computer, everything is running in one computer. You can always, you can log into this computer and do some stuff in production. I remember when I need to do a hot swap of some of the bug, we just compiled servlet code and FTP the servlet code into production cluster, and after that swap this class file. So that was amazing times, you know, the amazing times of Java EE, Java 2EE blueprint. How many of you remember what is Java 2EE blueprint? This is for those of you who were not around that time, there was a kind of reference implementation of enterprise Java application using Java EE technology. And we have a layer of data, or data access layer. We have a layer of business logic where we writing our actual code, and there's a presentation layer, 3-tiered application. I remember the times where everything can be running on one computer. Even database, application server, everything can run on one computer. But we seriously, we wanted to do better, right? We wanted to do stuff with this slightly better. So we started separating concerns. Databases needs to be managed by DBAs and running on a separate servers. Application servers would be managed by a group of people who understand WebSphere, WebLogics, and JBosses of the world. And we as a developer, we need to build WAR files, or if we're extremely unlucky, we need to build AR files and just throw it over the fence. And other people will figure out, right? So that's how we were deploying things. But times has changed, right? So now we're trying to do, we're breaking things down. So we are refactoring everything to microservices now. Everyone is building microservices. How many of you continue to build monolithic applications and probably continue to do so? Quick show of hands, few people. Okay, so microservices then, right? So on the same page, we want to be cool and build some new stuff. My name is Viktor Gamov. I work as a principal developer advocate at Kong, cloud connectivity company. Our goal is to build tools to help you succeed for building microservices, for building monolithic applications, for building anything that you have that has some sort of API, that may be exposing some sort of API, or you're building some sort of API. And I will be talking about some open source project that we donated to CNCF. It's called Kuma, and it's going to be service mesh implementation. Specifically, it is a control plane. And I will break down what does it mean, control plane. So in this presentation, I'll start with some of the theoretical background, bring you up to speed, and hopefully I will spend some time showing you some cool demos so you will understand how these things work in reality, not just on the slides, all right? So containers changed everything. Containers started this revolution. We remember this promise that write once, run everywhere, but containers actually ultimately implemented this idea by write once, package, and ship everywhere. And the containers help drive this microservices evolution. People were writing microservices even before the containers were there. You can write your microservice with simple like executable Java, Java jar, and it's also a microservice. However, containers allows us to ship the software more efficiently. And with the tools like orchestration tools, emergence of the Kubernetes, help us to be even more productive and spending more money on the cloud by swiping credit card and YOLO. So let's get back to this picture. I really like this picture because it's, again, remembers so much time spent on the EGBs and all these things. And many times, I work as a consultant, and many times when I came into the project, I picked up some of the common problems where the people were facing. One of the common problems, many of you probably know this, is when you're trying to use database and you need to use some sort of connection pool because you're either using underperformed database or you don't have people who can optimize it, or you need to pay the expensive licenses to have a more performant database. So those times you need to implement very interesting tricks. You need to deal with the connection failures, and this is how the life looked like this. But this service runs within one application. You can have a business logic service. One service will call another service, and that's how we were writing our application. So business logic was implemented something like this. However, from CPU-based computing, we start moving into network-based computing. So once we start breaking down this monolithic application, we bring in things to network more. So instead of doing the object do something, we start doing the network calls or API calls. It can be REST calls, it can be gRPC calls, it can be GraphQL, what have you. Or even RMI. How many of you remember RMI? It's pretty cool. It was pretty cool technology, and basically all these young kids just reinvented RMI and EGBs in gRPC type of things, right? Because it's a remote procedure call. You have a stub on the client. You have some of the framework that handles serialization for you. It's the same thing, but apparently it's better. So, and many things we need to solve in our applications, in our microservices environments, because in the past we just like pack this into war file and throw it through the fence, as I already said. Now we're responsible for handling some things around how our services would be resilient, how we will handle identity between the services. I spent a little bit of time yesterday talking about the security aspect of our application, so I'm not going to go very deeper into this one. So. And again, get back to this like a very simple use case. If we have a problem with our database connection unstable, we need to apply certain techniques, connection pooling, some of the retries, and we usually delegated this thing to some library or some framework that help us to handle this. Or if we were like have extra time or extra expertise, we might implement this stuff ourselves. And network always existed. It's not like we start moving from monolithic to microservice and all of a sudden there is a network. Network always existed. The network always was the biggest problem or biggest issue in our system, like something when every time you're the system administrator will tell you, oh, we have a super resilient network, or something would be it's not a network. So it's always a network. It's always either network or DNS. And it still continued to haunt us in 2022, if you remember recent outage on the Cloudflare. Now, and this solving those cross-cutting concerns inside our application code just created more and more problems. We just need to bring more frameworks. We need to see if it's a vendor-based framework. We need to make sure that the vendor will support us. If it's open source, we need to take care of the updates of this framework and so far and so on. With the introduction of some of the modern tools, for example, Spring spent a lot of time on providing kind of like opinionated ways how they can ship the software. They start shipping this in bundles. So when you getting new version of Spring Boot, it actually updates some of the libraries that were tested, and they spent a lot of time to fix that. Now, when we start building this microservice, how it looks like from typical Java application. So, when we need to interact with other services, we need to, first of all, find a way how we can discover those services, right? So we need to implement something with service discovery. There's a framework that the Netflix established because they were like pioneering some of the microservices, and some of the patterns that they established in their open source work were inherited and used in the Spring Cloud and the Spring Boot frameworks. So Ribbon, one of the libraries that allows you to do client-side load balancing. What is client-side load balancing? Before I started doing these jobs with this company, I was more on the back-end side of things, and I was doing the Kafka, and I was doing some of the big data stuff, for me, load balancer, it was something like Nginx. You throw in front of your application, and it's going to be round-robin load balancer. Apparently, there's a thing called client-side load balancer, and I should know about this as well, because tools like Kafka, they provide this client-side load balancer out of the box. When you connect in your producer and consumer to Kafka, first it goes to discovery or a bootstrap server, and after that pick up the connection to the actual Kafka nodes to get access to this one. So this is the client-side load balancer, and your application also needs to have these capabilities if you want to connect to the different services. So we start talking to Eureka, which is one of the examples of the discovery services. Essentially, it's a database that provides you with the catalog of the services. You can say, oh, I want to go to invoice service, and Eureka gives you whatever identity you will be able to invoke. It can be URI, fully qualified domain name, or something like that. But if you remember, there was times where we used another thing as discovery service, GNDI, Java Naming and Directory Interface, right? It was your discovery service, basically. Now, we need to make sure that we have all these retries in place, because network is unstable. We cannot trust other applications. Something will break anyways. So we need to implement some sort of retries, circuit breakers, make sure that our application stays up when some of the dependency will go down. So we need to implement something. There was again, library from Netflix called Hystrix that also influenced a lot of work that people doing with Resilience 4J. Centralized configuration, how we integrating with the systems where we can update config, and this config will be propagated. With the day two responsibilities that we as developers now need to do ourselves, not relying on operations people, we need to collect metrics. We need to collect all sorts of information. And for this, we also need to maintain some sort of system of record and Prometheus, and something like Grafana to do visualization stuff. All those things are also were available in the past. There was you can get some of the data from JMX, right? So JMX is one of the interfaces that your Java application can expose so you'll get all these metrics. However, things are changed in the sense that things simplified. Things like a micrometer in Spring Boot help a lot on the kind of like standardizing how we're going to be exposing all those metrics. In order to understand what the hell is going on when our application is down, logs and metrics most of the time is not enough. You need to understand the whole chain of things, so that's why you also need to traces. Traces, it's a special additional information that you include with your request, so you will be able to store this information in some sort of system that show you full timeline. You have a service that calls another service, and now you understand how much time you spent in response, how much time you spent on network. So all this information you need to build in your application. And this is not something that unusual, right? If you're not doing this today yourself, most likely you don't know what is going on with your application in production. And it's more kind of, if you cannot control something, if you cannot measure something, you cannot control it. So those things are must. It's not like it's a nice thing to have, but those things are must. However, there's an interesting problem here. Even frameworks like a Spring Boot, solving the problem of shipping different versions that compatible, so that's why when you're getting like a Spring Boot, you're not specifying version anymore. You have one version of the Spring Boot, and all these things comes from the bill of materials. It's a kind of dependency descriptor. And the Spring people and community will be responsible for making sure that your application actually, all these jars are compatible. So, and if you need to get access to outside world, you need some sort of like API gateway in front of this. Netflix also popularized the concept of Zool, which was a API gateway. Now it's a Spring Cloud gateway. But also, it's like you need to code this and you need to provide this as a part of your infrastructure. So many things you need to do as a developer, right? So many things. What you actually want to do, so your microservices becomes not super micro anymore. It's already like a distributed monolith rather, because each application of this microservice will include those libraries. All those things will include this stuff. And just bear with me, because this is where I want to introduce you something, and this is where we stepping into the world of the service mesh. So what about, like, we get back on the good old days where we can, throw in things over the fence and someone will handle some of the responsibility for us. The times where the application server was configured for us, and if we need to configure to connect to database, we're using GNDI name. This is our service discovery. Application server already provided us with the connection pooling mechanism through the GNDI. We're getting connection, not direct connection, but connection for connection pool. There's something similar in this pattern, but available in microservices world. What if we can take all these pieces of functionality that ship you as a library, but externalize it as an external process? Just take this out. Your application will be focusing only on business logic, but we will take this, and all these cross-cutting concerns will be solved on the side of this small process that will be running next to your application, that will be small enough and performant enough so it will not introduce additional latency in the path of the request. It would be capable enough and smart enough to report about what is happening there. All sorts of information about the traces, information about metrics, collecting logs, and all this information will be available. So that's what we coming into the service mesh. So once we have this proxy server, our application really don't need to do anything, because it will be just thinking that when it talks to some external world, everything would be happening locally. And the proxy will be responsible for doing service discovery. Every time when you required connection to database, you will talk into database.mesh, and after that, it will be magically, or technically it's not magically, it's going to be DNS or some sort of other resolution mechanism, but the address will be available and the connection will be established for your application. And the interesting thing here is that this proxy will be talking to each other. So your applications don't talk to applications directly. So your services don't talk to each other. They talking through the proxy. And because the proxy now standing in front of this like a request path, it can do some of the magical things, including some of the retries, error handling, logging of this information, handling some security, because this connection between the proxy servers can be established and can be secured and encrypted. And now we're getting back to this the very similar situation that we have before network in the monolithic application. So either dependency injection will be responsible for injecting implementation of certain service when we're running as a part of the one application. Now, this system that will be managing would be injecting these proxies and will be providing those proxies for every service that will be running inside our mesh. And it's going to be also distributed, and some of the cross-cutting network concerns will be handled as well. I like to talk about Kubernetes a lot because it's a great tool and it speeds up my personal productivity and speeds up productivity of other people. Plus, helps the cloud providers to charge me more. But you know how you can put the price tag on productivity when you know I'm happy in building apps and I'm not miserable anymore. But apparently there are other places where the people deploy applications. Still, places where we have VMs and people still deploy applications in VMs. Applications can be deployed in Kubernetes environment, non-Kubernetes environment, in containerized environment, non-containerized environment, and the system also needs to be like this kind of heterogeneous. Some of the service meshes that were designed, they were put the target. We're going to be running only in Kubernetes. We will be depend only on Kubernetes, and it will be putting like a very high bar. The Kuma that I will be using as an example is what we call universal service mesh. You can run this in any type of server environment. You can run this in cloud. You can run this on-prem. You can run this on VMs. You can run this on containers. You can run this Kubernetes. And those things would be unified, and API would be the same. Control plane and data plane configurations would be the same. Now, there's one problem. We got this nice tool that will be established in connection, but we didn't talk about configuration management. So configuration management was one of the big parts on the previous slide when I showed the microservice and how we can configure this. Now, the normal idea it would be like if we deploy this application, we will ship this configuration together with our application, right? But if we need to change this configuration, we need to figure out the way how we can either do new release that will include new version of the configuration, and after that we'll ship. But it's going to be cumbersome, right? So in this case, we're going to be focusing on, again, APIs. And what if there would be something that provides the API that would be configuring this proxy, not statically, how we configured, how my dad was configuring proxy, how his dad configuring was proxy, going into server.conf and changing something. What about dynamic configuration? So this is where the actual, the secret sauce, but it's not that secret because it's open source. But essentially, the proxy that I'm talking about, it's Envoy, and many service meshes are actually using this. It's a small proxy to do this like a sidecar pattern. But the way how control plane communicates with this proxy and how the control plane would be responsible for updating this configuration and keep this configuration up to date, this is where all these interesting things are going to happen. Give me a second, I'll go do step back. Yep. So essentially, data planes in our case, this is something that will be standing in front of your request. And as you can see, there is no direct connection between this control plane thingy and your application. So even if the control plane will go down, your application will still be performing because data planes still will be up and running. And congratulations, this is how we invent the service mesh. So this concept is really simple to understand. You have some sort of data plane that would be managed through API through the control plane. You have a centralized control place where you ship this. When I said centralized, it not necessarily is going to be single point of failure, because you can have multi-mesh deployment that the Kuma also supports. And all these type of things can be solved. Speaking about the multi-meshes, you can span this overall mesh across multiple data centers, across multiple, you can have data center in the cloud, you can have data center on-prem, and you can span one service mesh that for your application, they will appear like they're running on the same thing. And you can have the traffic rules in terms of like, okay, so this service cannot go across data center traffic because it's expensive. And all this type of things can be configured inside this service mesh thingy. All right, from perspective of architecture, each data plane component will include small process that's called Envoy. Again, a small proxy was developed at Lyft and donated in open source, and now it's also CNCF project, and many other companies continue to contribute to this one, written in C++. Probably that's why it's fast, but because smart people working on optimizing this its performance. Kuma, it is a control plane that runs, like I said, in Kubernetes. It can run in anywhere where you want to run this. It has its own database for storing configuration. It's responsible for invalidation this configuration across data plane, and so far and so on. Whew, finally, okay, I was tired about slides. How about you? Let's do some demo. So, what we're going to be doing today in terms of demo? I took the idea, highly inspired of this idea from my friend Raitzen. He used to work with Google, but he's not with Google anymore. And he had this idea of how he spends his time. So probably that's why he's not in Google anymore, because he was going to meetings and he was sleeping on the meetings. And he was like brave enough to talk about this from the stage. So probably his boss learned about this, that he was sleeping on the meeting. But not to the point. Point is that he implemented the idea of application where you can have one service that will start the meeting, and this service will be written in Spring Boot. And as an implementation, that's what we're going to do in our meeting. So that's what we're going to spend our time. So 250 milliseconds sleep. And we will have another service that will be using Micronaut. And the reason why I use those two frameworks, just simply, I'm not using any features that they include, like things that I already mentioned with metrics, integration, with the circuit breaker results. I just use it because they provide tooling for build containers faster. I hate writing Docker files myself. I just want to write my code, and after they say Gradle build image, and I'll have a Docker container. That's it. The only reason why I'm using this. I can use this just for the simple public static void main application. Same thing. I just use this because those frameworks already include this. And I do have this work server. Like every time when I want to do some work, I will expose this API. And what this work server will do, it will call my meeting exactly 4 times. Exactly 4 times, and after that, we return how much work we did and how much time we spent. 2 services, easy, right? One service is running, exposing one REST endpoint, another service exposing another endpoint. When we call in one endpoint, we're calling this meeting endpoint. So the way how it looks like from perspective of local development. I love Spring Boot because I can do stuff like this. That's awesome. Anyway, so this is the meeting application, and I will be calling this localhost/meet. Doesn't do anything. However, if I go to logs, It says like I'm on the meeting. Also, it captures some of the headers just for us to trace and see what kind of things are the service mesh can add as a part of the headers, for example, because I will be showing you some of the tracing stuff. Now, and second service that written in using Micronaut, I didn't figure out how I can do the text logo here, so that's why Micronaut. It runs on port 8080. And I'm going there and invoke this, go on working. 1 second-ish. And I went for 4 meetings. So I have 4 meetings. Like every time when I get the 200 response from my meeting server, I'm getting count +1. So one of the things that this service will be required. Also, I like to use things like dependency injection, and the Spring Boot and the Micronaut providing the ways how I can do a dependency injection. So that's why I'm including this URL of the service that I need to invoke. So if I'm not specifying this meet URL and configuration, I by default will be using this localhost thing. But what I wanted to do in an environment where I will deploy, specifically in Kubernetes, specifically under service mesh, I want to do this with service discovery. So I can inject the thing that would be like production or not production thing. So the way how it works, this meet URL can be overwritten by capital meet _ URL environment variable. And this is how I will be injecting things when I will be deploying this into Kubernetes cluster. 2 applications, easy enough. Now, we're going to look into some of the Kubernetes manifests. So for my meeting deployment, I have 2 things here. One thing is my deployment. So what is deployment? How many of you have a good understanding of Kubernetes aspects? Just for me to understand how much time I need to spend explaining. I see a few people, okay, so half and half. So I will spend just 20 seconds explaining what is deployment. Essentially, Kubernetes, it is a kind of service that serves all your requests and it fulfills your requests. So if Captain Jean-Luc Picard will say, make it so, Kubernetes will go and make it so. If you want to say, hey, Kubernetes, please deploy my application, I don't want to know where you're going to be deploying this, how much time it will take. I just want to say, my application needs to be running there, and that's it. So Kubernetes will take this and it will allocate resources. It will ship particular the container into particular node, provide all the networking, and all these things will be available for you. So that's the only thing that you need to know from this. And this deployment, it's basically your desire, your intent, what you want Kubernetes to do with the world. And Kubernetes can fulfill it, or it can say, I couldn't. Another thing that Kubernetes also have this concept of service. In order to this application will be available to from within the cluster, we need to assign this some sort of load balancer as well. So this is why service, we're saying that this service, meeting service, will be available through name. So that's how we can do service discovery in Kubernetes. So inside our namespace, we will be able to locate the service, and even from outside of namespace, we have a specific URL how we can locate to the service. So that's a very nice thing to have. And only thing that I need to specify here, this is the image that I built and deploy. Same thing for my work deployment. Only difference here, I want to inject this thing. But this URL, let's start without this URL. We will change this. We will change this after, and like this, because this is what the service name. This is the standard thing that Kubernetes will provide me. So what I will do here, I'll just go ahead. There's nothing running on my net. There's no namespace that I want to run. I just do create namespace, and when I do scaffold run in. So the scaffold, it is the command that allows me to automate certain steps. It allows me to clean ups afterwards, but essentially it just takes all these files that I just wrote and will create these resources inside the Kubernetes. Plus, it also waits until these things will be available. For example, I have this namespace. That's my applications are up and running. Micronaut is up and running. My meeting application. Look at that. Look at that. Sorry. Yeah. So this application also will be available. Now, how I can test if it works? Easy peasy. Let's do this one. Let's do bigger screen. And we'll just do a little bit bigger. Yeah. So I can run the I can deploy just like an arbitrary container that will include curl. So I will be just to test if my application is still working. Now, if I just do curl meeting 8080/meet, I get nothing, which is fine, because I see this is a response from my Kubernetes. I see this is a curl, all good. And now let's see if our dependency or like a service discovery works for our work server. 8081/work. So a few seconds. Yeah, so it works. So we use this concept of service discovery from Kubernetes, and all nice and cool. So the service is deployed. Now let's talk about what we can do with service mesh in this particular case. I already have this thing up and running in my Kubernetes cluster. It already runs some of the services. I showed some demo yesterday. This is my shop, kong.me.sh. It's also running the same cluster, also runs under service mesh. That's what I showed yesterday, so that's why I don't mind other services running here. Now, if I go and see what kind of data planes I have here, so it's the standard data plane. And let's see, meeting. There's no meeting, there's no work. So there's nothing. So those services not available. Those services are not a part of my service mesh. How I can enable this? So I can do and create this the manifest inside my YAML files and say, okay, so include this sidecar container, include the connection to this data plane. But there's a better way. So I can go ahead and click this thing called Create Data Plane Proxy. It will join same mesh. And after that, I want to say it's going to be a mesh for Java. I should have called it mesh for J because this is kind of more canonical way to call things about the Java, but hey. So it gives me this nice snippet that I will be putting here and executing. What it does, it will actually modify my namespace where I'm running these applications. And I will restart all, let me show you. So right now, if I'm running this in my namespace, my pod is the unit of deployment that we run inside the Kubernetes. Pod can include multiple containers, so it's not like it's only one container. In general, most of the time, your pods are including one container. However, it's going to change in real soon. We're going to be injecting another container next to my pod that's called sidecar. So this sidecar container will be responsible for handling all the traffic, and after that, delegated some of the calls that will be directed to my application. So that's what I'm going to do. So with this command, I'm adding this annotation, set sidecar injection enable. So every time when I will be adding new pods, this thing will inject additional containers. So what happens here while we are running this? The containers always stay in the state where the Kubernetes constantly checking if they're healthy or not. And if they are not healthy, Kubernetes will be responsible for restarting those containers. So since I went there and deleted all the pods, how they reappear here? So that's why we need to use deployment, because deployment, this is the kind of thing that allows us to build resilient resilient deployment strategies of applications. So we killed the pod. However, in some memory of Kubernetes, it knows, oh, there has to be those pods has to be running, so I need to recreate those. So Kubernetes went and recreated, and the reason why we don't see curl here anymore, because curl was not a deployment. Curl was just a pod that I was running there, like similar to kind of running some arbitrary container. Now I have two containers here. So now there was a sidecar injected, and immediately we should see those things in my data plane proxies. And all of a sudden, I start seeing this is meeting service. Multiple things can be here. Where is it? Standard data plane. And I go to my meetings. Some interesting tags I see. Some of these tags inherited from standard service. Some of the tags were injected based on certain knowledge. For example, now I will be able to get access to the service with this name. Regardless where the service was deployed, it will be deployed in one data center or another data center. As long as the service mesh is spanned across those, like some infrastructure already spanned across the service, this thing will be available for me. So let's play around with this concept. So this URL looks kind of like kind of meh. You need to remember all these things. So what if you want to do something like simple? myservice.com, that's it. It's easy to remember. So the service mesh and Kuma provides this built-in DNS server, and it provides built-in DNS zone. So .mesh would be the zone that's available for everyone within this cluster. But I also need to do some of the modification in terms of how to remove this service, how to remove this port. And this is the first thing that we're going to touch. It's called a resource that we need to configure in our service mesh. It's called virtual outbound. So what it does, for all services, it will run some transformation, and it will extract Kubernetes service name, and will use this as a, I just want to extract only this part. I don't care about namespace. I don't care about this SVC. I don't care about port. I just want to have a meeting.mesh. So that's what I'm doing. So I will go ahead and apply this to .mesh created. So now I can go ahead in my where's my work deployment? Here, I can actually do now thing. I don't care about port. I don't care about anything. Meeting.mesh. That's what's going to be. That's how it is going to be working. And I'm going to run my scaffold run. That will be checking if it requires to update any. I should have just run this manually. But anyway. So now those services are deployed inside my cluster. How I can get access to the services to outside world? Actually, you can also get access to those things. In my configuration, I have this concept called ingress. Where is it? Ingress. That makes this service, this work service, available to outside world. So my ingress will be served by another data plane that also part of the mesh, but it has a different ability. So this data plane is not running inside the mesh only, but also it runs as part of the mesh and also exposes to outside world. So I'm running this con gateway, and I also expose this thing to outside world. So if I go ahead into my where's my insomnia? So I will do this. Okay, not found, which is a good thing. So DNS is always a problem, so that's why let's try. Maybe DNS updated. Maybe I don't need to use the host name. So let me hide this and see if this will be also available. Okay, it actually works because sometimes when updating DNS, it's not immediately work. So Now, you can go and do this yourself, by the way. Yeah, you can do this and you can get this answer. And now what is going on here? So first of all, I'm getting some of the interesting headers here. So this request actually going through multiple different hoops. And we can see that our initial request was served by Envoy. This is our data plane that was sending our traffic. And another one was served by our gateway. So application will be up and running. Now, all these things are working. So I have updated the configuration. Now I have a service discovery. Next thing is that I also want to have observability out of the box. So I have in my server deployed Grafana and Prometheus. And also in my service mesh, I already have this thing configured called the metrics backend. So I'm shipping metrics to Prometheus. I'm shipping tracing to Jaeger, and I'm shipping logs to Loki. So in my Grafana dashboard, so what I will do, I will show you first of all service-to-service communication, how I can get this information out of the box. So this dashboard also shipped with Kuma, so all these things is available to you to use. So we want to say the service that initiate the traffic call is going to be work service, how it is talking to meeting service. And let's see, not the last hour, so last 5 minutes. That's what we have, like few requests we send there. In order to generate some traffic, let me just go ahead here. I will just do repeat on interval, say every 2 seconds, we're going to be sending this request. And we will see how this thing will generate some additional traffic. Now, so we get this metrics immediately out of the, my application doesn't have anything to do with this. So this application, these metrics are coming from data plane proxy. So on the traffic level. So I don't need to implement this as a part of my application. Next thing is that I can also go ahead and look for say logs. And in this case, I'm gonna say app is gonna be, where is it? App, and we're gonna say work, and we're gonna see show logs. And all these logs would be picked up because the sidecar has access to logs that are available in. So you see, this is output from my start of the output from my Micronaut. Some of the output comes from a underlying Envoy proxy. For example, this information about getting HTTP call to meeting.mesh, because again, my work application is not calling directly my service, it's calling through proxy. So we have all this thing information. So logs are available in centralized place. So, and another thing that I want to show you quickly with this, we have a mesh. We can see like a visual representation of what is going on in our application and how the services communicate. And the last thing is that let's introduce something funny. For example, I can introduce, since I also have a control over the traffic between the services, I can actually introduce some of the failures. So in this case, I will say every time, like every request, just fail, just send for 100 requests. When the traffic comes from work to meeting, do it. Just, make their life miserable. And fail 50% created. Now, so how we can monitor if it actually does what it's supposed to do? See, now I'm going to only 2 meetings because every other call will be failing. Now 0 meeting, it's fun. 2 meetings and 1 meeting. So not exactly super deterministic, but that's what's happened. And if I go ahead in a panel that we were seeing like a server-to-server communication, I can show you that we're also capturing service-to-service. Let's just do work, and we'll just do meeting. And now I also start seeing there's a, not the hour, 5 minutes. refresh. Now I also start seeing the 500 response in this one. So with this, I can do another cool thing that will immediately enables a secure connection between my two systems. So what I will do, just uncomment this built-in certificate authority to generate certificates for my service. I will just go ahead, and all of a sudden, the connection will still continue. You will see there's nothing will break, but you also will see, if I will go and see TLS report, if all my applications will get their own certificate, and now connection between the things would be secured. So with this, I hope I introduced you some of the different perspective on the way how you can deploy your apps and how you can think about your infrastructure, not putting infrastructure into your application anymore, but using underlying technology to serve the traffic. I hope it will give you some ideas what you can do, and maybe in future you're gonna try this. Where is it? Why that not showed few links. I am doing more or less every 2 weeks, and my colleagues also doing live streams about all things around connectivity, metrics, DevOps, cloud, Kubernetes, and what have you. So I hope I will see many of you on my YouTube channel afterwards. And with this, my name is Viktor Gamov, and as always, have a nice day.